So let's see the questions. Okay, here is the set 1 is about the calculation of Kc. So here shows for 26. Okay, now if the given information is this one and the Kc is this, so have a look on the equation we need to deal with. Okay, it is actually the reverse version of the reaction one. So the Kc, because Kc is the product concentration over the reactant. Okay, so for the reaction 2, Kc2, it should be 1 over 0.8. Yeah, then we need our calculator for help. Is 1.25. Now, because Kc1 here doesn't have any unit, okay, so Kc2 also don't have any unit. So the answer is boy. 27. Okay, here given the volume, okay, the decomposition of Hi, that means the Hi should be the reactant, and the H2 and I2, all of them are gas, so it should be included in the calculation of Kc. Here shows the expression of Kc, Hi square. Okay, see what information we got. In the equilibrium, we got this amount of Hi, this amount of H2, and this amount of I2. So it should be okay. Now, don't forget we are dealing with the concentration. So don't forget to divide by the volume. Okay. It is essential. Okay, sorry for the color. Okay, is 0.1 over 3 to the all square. Okay, well, with further algebra, you can see this is 0.6 square, 0.1 square. Okay, here again there's no unit. Okay, so the answer is D. 2017, 31. Well, this question is only about 56% of student correct. So let's see what's wrong. Okay, now again, at equilibrium constant is 2.5 in the experiment. Okay, the total volume. Okay, so in the starting, okay, T equal to 0. Okay, W X Y and Z. T equals to 0. Okay. Okay. Now this is a closed container. So what is the volume? Is 0.2. Okay. So time equal to 0 is 1. X is 1 and no X. So no Y and Z. But okay, the story hasn't ended here. Again, we need to divide by the volume. Okay. Now, so the Kc is given 2.5. So what will be the concentration in equilibrium? Okay. Now, still remember the RICE, RIE, and what we're missing is C, the change. Okay, the change will be 1 minus X. 1 minus X. Oh, sorry. The change should be minus X plus X and plus X. Okay, the number of mole. So the equilibrium concentration should be 1 minus X 0.2, 1 minus X 0.2, X 0.2, X 0.2. Okay. Now RICE all are here. Okay. So the Kc will equals to X 0.2, X 0.2, 1 minus X 0.2, and 1 minus X 0.2. Now, further elimination, that is x squared over 1 minus x to all square equals to 2.5. Okay, now let's see if we can do something. Okay, we take the square root for 0.5 is 1.58. Okay, and that means 1 minus x equals to 0.63x. Okay, and 1.63x equals to 1. X equals to 0.61. Well, looks nice because this is acceptable. Okay, this range. So the answer should be boy. This is question 27. Okay. Question 27 is given. Okay, let's see what information we have. Kc, volume. Okay, the mixture of this one. Okay, now, so again, let's try to write down our rice, RICE. Okay, 2x y 2 become x2 and y2. Okay, double. Okay, this is equilibrium already. Okay, so the answer for Kc is x squared. So no, x2. X2, well, is n over 10. Okay, y2 is 2 over 10, but this time we need square. Okay, and the reactant is 1 over 10. Again, we need to square. Okay, after doing some calculus, this should be 4 and 1,000 and 100. Okay, so further elimination is 4n over 10. It should be 0.4n, and according to the given information should equal to 0.6. Okay, so the answer looks like n equals to 6 over 4. It is 1.5. Oops, 1.5. So the answer is A. Okay, hope you understand. Next one, we try to express the K3 in terms of K1 and K2. So the K3 actually equals to A, B, E, F, and G. Okay, so let's see. For the K1, AB is in the denominator, so we should do something like this. 1 over K1 looks better. It should be A, B, C, and D. Okay, if we study K3, E, F, G are in the denominator, but in K2, E, F, G should be denominator. So what should we do? Again, we should have K2, the reciprocal, that is CD, E, F, and G. Okay, so 1 over K1 times 1 over K2, we can eliminate the CD and get what we want. So K3 is actually the product of 1 over K1 and 1 over K2. Okay, and this either A or B, right? Okay, so next one is what is the unit. So for the K3, the denominator is mole per dm cube all square, but the denominator is power 3. So the final unit should be mole minus 1 power and dm 3. So the answer is boy. Looks good. Okay. 27. For 27 is, okay, again, let's check. We got, okay, this amount of volume when the equilibrium is reached is 0.4, 0.3, and 0.4. Okay, the value of Kc, so very good. The Kc equals to 0.4 over 2 to the all square and 0.4 2 and the y is 0.3 2, but this time we need triple, okay, to the product. Okay, let's see. Yes, 0.2 to the all square, 0.2 0.15 to the cube. Okay, cross out. Okay, use our calculator. It's 59.3. Okay, very good. This is D. Okay. And okay, finally, this is the final MC for this part 1. Okay. Okay, again, check the volume. Okay, undergo decomposition starting with 1 mole. Okay, so what the result will be? So, okay, X2 is the reactant starter. Okay, that means we won't be C and we won't be what? No, okay, because it started with because in part C, X2 increased, so do not fit the our idea, right? And the second hand is, so what about the X? Okay, because the mole ratios it should be 1 to 2. So for example here, okay, take A as an example. From starting to the ending, for X2 we drop 0.6. Okay, then the X amount should increase double 1.2. Looks nice, right? But this one, starting with 1, ending with 0.6, so drop 0.4. But this one increased 1.2, so it doesn't fit our idea. And how about this? Starting from 1, final is 0.4, drop 0.6, but only increase 0.8. So again, do not fit our answer. So for these questions, the answer should be A.